Okay, and on to question 6, which is a lovely circular measure question with triangles and arc lengths and areas and everything. It's got, I guess it's one of the more complicated one that we've seen so far because it has got 3 different sections to it. But I guess it just means a little bit more work to do, but the parts by themselves aren't any harder. Okay, you've only got the formulas for either the area of a triangle or the area of a sector or obviously the arc lengths to deal with. Okay, so part 1 is we're supposed to find that length AC, which is this length down here, in terms of r and theta. Okay, so the first thing I can see is that I've got this whole sector part here where that side is r, and this side here should also be r, right? This whole side there, because it's all coming from the same centre point of the circle. And this AC part here's what I'm after. So what I need to do is find out what this part here is. Change colour. This part here. So the part between O and... is that a C? I've just blocked it, haven't I? I think it's an OC. So what's the length there? So from O to C. And then once I found that, I'll take it away from R to get AC, which is what I want. Okay, so how do I get OC? Well, I've got a triangle. Got an angle down there. I know that the radius is there, and I'm trying to work out this part here, okay, which is O to C, this part down here. Okay, and it's a right angle triangle. So I can use some trigonometry. I've got an adjacent and I've got a hypotenuse. So the cosine of that theta is going to equal x over the radius, and so that means that that length OC, which is x, equals the cosine of theta times r. So now we know what this part here is. That part there is the cosine of theta times r, and this whole length is the same as the thing, which is r. So therefore, the length AC, which is what we want, is r minus cosine theta r. Okay, and on to part 2. We've got to find the perimeter of the shaded region. Okay, so they've told us for this one here what the angle is. So I'm going to actually just redraw this diagram bit by bit and show you how to get each unknown side as we do it. Okay, so I'll start with the triangle part there. They've told us now that that angle is a third pi, which is exciting because a third pi is the same as 60 degrees, which means it's one of our, we can use the special triangle idea with it. Okay, they've told us the radius is 4, so that's there. And so straight away we can use right angle triangle, trig ratio type things to work out the other two sides. We sort of hinted at that in part 1, and now we can do it for real in part 2 because we've actually got some number values that we can do. Okay, so this is a special triangle idea. So if the side of my triangle is 4 there, if I imagine I've started off with an equilateral triangle with an angle 1/3 pi, normally the one we give you has got sides 2, right? But you can make the sides whatever you want to make it work for the question that you're solving. And so in this case here, sides 4 would work better for us. So as long as all the sides are 4, it's an equilateral triangle, and then we'd cut it down the middle, which make the base 2. So there we go, we know straight away that the base has to be 2. And what we want to know is what's the height of this triangle. Well, the height of the triangle, actually now we can just use Pythagoras. So 4 squared minus 2 squared. So 4 squared is 16, minus 2 squared is 4, so that there is going to be the root of 12. Okay, so then on the other part of this, we've got, on the other side of this AC part here, this whole arc length there, and this small arc length here. Okay, now what we know is that the radius for that way has got to be the same as the radius across this way. Okay, so if 2 of it is on this part here, the other part AC has to also equal 2. And if we wanted to, we could have recycled our answer from before, which said that we worked out that the side AC was the same as r minus r cosine theta already. Okay, so that would still give us an answer of 2 if we work that out. So that's fine. Are you with me so far? Hopefully. Okay, so what we need to do now is we need to break up this height here into the CD part and the D part and the DB part. So we know that CD and CA are the same length because they're a quarter of a circle. So it means we can put 2 to go between there and there to make the quarter of our circle. What we need now is this part here. Okay, but if the whole height is root of 12, then this part here must be root of 12 minus 2. So this part here must be root of 12 minus 2. Okay, so that's one part of the perimeter of the shaded area. The other two parts now are really easy. That's the hardest part. The other two parts are just using arc length to work it out. So this part here is going to be the r times theta, and theta in this case is pi over 2. 90 degrees is half of 180 degrees. So that part there is going to be 2 pi over 2, and of course that 2 and that 2 will divide through, so it just becomes pi. Okay, so we've got two parts here, root 12 minus 2, and we've got pi. And now we just need this last part here, which is the same as the big arc there. So that big arc there has got a radius of 4 and an angle of 1/3 pi. So if we simplify that, we get 4 pi over 3. So those are our 3 components of the perimeter of the shaded area. So if we add those all up together, let's move that for a second. Oh, where was that? Then what we get is the total perimeter equals root of 12 minus 2 plus 4 pi over 3 plus pi. And we should really do a bit of tidying up at this stage. So let's tidy up this 4 pi over 3 plus pi. They're both pi in terms of pi, so we should collect like terms. So that's 4/3 pi. This is going to be the same as 3 over 3 pi. So when I combine those together, I'm going to get 7 pi over 3. Okay, so 7 pi over 3. And this last one here, so this, what we should do is thirds, and we haven't done a whole lot of this because it's not like a massive big skill, but is that you should see if there's any way that you could simplify this. And what you're looking for are there any ways that you can multiply to get 12? So factors of 12, where one of those factors you can take the square root of. So for example, if I do this as the square root of, leave that minus 2 there as well, 4 times 3, for example, 4 times 3 is 12. I still keep that all under the same bracket, but now I can take the root of 4, which is 2, and leave that third only with the 3 part, like so. Okay, so I would get, I'm going to move that up again, I'm running out of space. There we go. So I would get, here for my answer, 2 times root of 3 minus 2 plus 7 pi over 3. And that there would be my final answer for my perimeter.